Okay, I want to pick up with solving polynomial equations, section 5.8, part 3 video. And so we had gotten down through our sixth example, which was F. So I want to pick up now with G, and I want to do very similar to what I did earlier. I'm going to pop it up and just let you copy it, and then I will go over it. It just works a little quicker that way as far as video time. So copy this, pause the video now. Okay, I'm assuming you paused the video, you copied the problem, so let's go over it. First, this is a second degree polynomial equation. So this is called a quadratic equation. How do we solve all polynomial equations of degree 2 and higher? Or how do we solve this quadratic equation? Step 1, bring all the terms to one side, leave 0 on the other. So I've got to subtract the 25 from both sides. Step 2, put it in the right order. It is. You said, now wait a minute, Mr. Rainer, it's missing a middle term. It is, but it's still in the right order. The x squared, there's no x, but then the constant equals 0. So it is in the right order. Step 3, factor the polynomial that's on the left. Okay, it's a binomial. What's the first thing we look for in a binomial? GCF. This doesn't have a GCF. After you check for GCF with binomials, there's only two other things to check. Difference of squares, sum and difference of cubes. Let's do difference of squares first. Is this the difference? Yes. Of 2? Yes. Perfect square, x and x. Perfect square, 5 and 5. So this is the difference of two perfect squares. So how does it factor? Do your two sets of parentheses. X squared breaks up x and x. 25 breaks up as 5 and 5. The signs are different. One's a plus, one's a minus. So that's where this comes from. Not finished now. Step 4. Set each one separately equal to 0. And then solve. And remember, what I'm doing here is I'm subtracting 5 from both sides. I'm getting the x by itself. Adding 5 to both sides. And if you check both of these answers up here, you will see that it makes that equation true. Okay? Let's go to our next example. So I will tell you in just a second. Okay, so pause the video now. Okay, I'm assuming that you've already copied this problem, so let me cover it up. This is a quadratic equation. Step 1, bring all the terms to one side, setting it equal to 0. Done. Step 2, put it in the right order. It is. You have the x squared first, you don't have an x, and then you have a constant, and then equals 0. Now, I need to factor this. How do we factor this? The first thing you do is you factor this left side. It said factor the left side completely. All right, this is a binomial. What's the first thing we do with a binomial? You look for a GCF. Does this have a GCF? Yes, it does. 2 goes into both of these. Now, not 2x because this doesn't have an x with it. But your GCF is 2. If I take out a 2, I'm left with this. Now, remember, if you'll look back at your notes, the third step does not say factor the left side. The third step says factor the left side completely. So, if you look at this right here, let's see if this will break down any farther. Well, let's see. This is a binomial. You've already done the GCF, so there's only two other things left. Squares and cubes. So let's see if it's the difference of two perfect squares. The difference of two perfect square, yes, 3x, 3x. Perfect square, yes, 1 and 1. So this is going to be 3x, 3x, 1 and 1, signs are different. Now, when you factor this, don't forget to bring down the 2. Now, step 4. Set each one of these equal to 0. Now you've got 3 things to set equal to 0. So set all 3 of them equal to 0 like so. Here's the difference. When you set all 3 of these equal to 0, what are we solving for? We're solving for what? X. Does this equation have an x in it? Sure it does, right there. Does this equation have an x in it? Sure it does, right there. Does this equation have an x in it? No. So, this part of the problem is not going to impact your 2 solutions because there's no x in it. Or here's another way you could say it. Does 2 equal 0 ever? No. So, that's not going to affect the problem. But I am going to solve these 2 for x to get my 2 answers, which I knew this problem had. So right here, I'll subtract 1 from both sides and divide by 3. And right here, you add 1 to both sides and divide by 3 to give you the 2 solutions. And again, I knew it had 2 solutions because it was a quadratic equation. Okay? Next problem. Pause the video now and copy this problem. Okay, so I'm assuming that you copied this video, so let's copy this problem. So let's look at it. First, this is an equation because of the equal sign. The goal is to solve it. What kind of equation is it? Well, it's a polynomial equation. But better, it's a second degree polynomial equation, and we have a name for that. That's called a quadratic equation. So how do we solve a quadratic equation? Step 1, bring all the terms to one side, leaving 0 on the other. Step 2, put it in the right order. It is. Step 3, factor completely this left side. Well, if I factor the left side, it's a binomial here. What's the first thing we look for in a binomial is a GCF. If you're not careful here, you will say that the GCF is 4. That is not correct. The GCF here is 4x. So I'm going to factor out a 4x. And when I factor a 4x out, if you divide 4x into 4x squared, you're left with x, minus, and 4x into 16x is just 4, equals 0. Now, if you say your GCF is just 4, you're not going to get to the right 2 solutions. So it's 4x. No, this doesn't factor again because this is not x squared. It's just x. All right, now what do we do? It's factored. Set both of these equal to 0. Now you have 2 equations. I can solve this one for x because it has an x in it. I can solve this one for x because it has an x in it. How do I get rid of that 4 in front of that x? By dividing. But whatever you do to one side, you have to do to the other. But 0 over any number is just 0. But how I get rid of this subtracting 4 is by adding 4. So the 2 solutions to this problem is 0 and 4. Okay? All right. Copy this next problem down. Now, let me make sure you've got everything in the view screen. Okay, yes, you do. Okay, pause the video now and copy this problem. Okay, so I'm assuming you've copied this problem, so let's look at it. First thing that sticks out at me is that this is a cubic equation. So I don't call this a quadratic equation, but it's still a polynomial equation where the degree is 3. So the 5 steps that I gave you, that solves all polynomial equations degree 2 and bigger. Not just quadratics, all of them. Or that's the process that you try. All right, so this is a cubic equation, but I still use those same steps. Step 1, bring all the terms to one side, leaving 0 on the other. So this 10x squared, I got to get rid of, and this minus 8x. So I'm going to minus 10x squared on both sides, and I'm going to plus 8x on both sides. When I do, this is what I get. And now it's equal 0. Now, is that in the right order? Yes, it is. You want your biggest power of x first. So you got an x3, an x2, and an x1 equals 0. All right. Now what I've got to do is factor this. Well, it's a trinomial. What is the first thing we do when we're factoring a trinomial? You look for a GCF. If you say, does this one have a GCF? It certainly does. The GCF, 2 goes into every one of these terms, but notice every one of these terms has an x in it. So your GCF is 2x. When I factor the 2x out, if you divide 2x into 2x to the third, you get x squared. 2x into 2x to the third is x squared. Then 2x into 10x squared is 5x. And then 2x into 8x is just plus 4. Now remember, the third step says factor the left side completely. So what I've got to do now is factor this, if it will. Well, it's a trinomial. I've already took out the GCF, but it looks like the easy case. So I've got to see if this will factor again. So I'll do 2 sets of parentheses. X squared is x and x. Signs are the same, both negative. X minus, x minus. 2 numbers that multiply to give me 4, but if I add them, I get 5. That's 4 and 1. So x minus 5, x minus 1, x minus 4, x minus 1. Now set these equal to 0. Set all 3 of these equal to 0. And when I set all 3 of these equal to 0, because now all of these have an x in it, I'm going to get 3 answers. So, how do I get the x by itself here? Divide by the coefficient. So divide both sides by 2 there. You're still going to get 0. Here, add 4 to both sides to get positive 4. Add 1 to both sides to get positive 1. So I get 3 solutions to this cubic equation, 0, 4, and 1, which I expected 3 solutions. Okay? 2 more examples to close out this section. Let's see here. Slide it over just a little bit and Okay, pause the video now and copy this problem. Okay, so I'm assuming that you got this problem copied all the way down. So let's go through this problem right here. First, this is a polynomial equation because of the equal sign. Polynomial equation, and it's a cubic polynomial equation because of the x to the third. Step 1, how do we solve any polynomial equation degree 2 and higher? We bring everything to one side and set it to 0. So I got to get these 2 terms off of this side. So I got to subtract 12 and add 3x squared to both sides. When I do, subtract the 12 across, and add the 3x squared. Now nothing's left over here. That's step 1. Now here's the problem. This, x to the third, x number x to the second. It's not in the right order. So step 2, put it in the right order. So when I put this in the right order, put the x to the third, the plus 3x squared, the minus 4x, and then the minus 12. Make sure you don't lose the signs. Keep the 4x negative, keep the 12 negative. So x3, x2, x1 constant equals 0. Now step 3, completely factor the left side. All right, it's been a while since we've done one like this. This problem has 4 terms. Okay, if it has 4 terms, first thing we look for is a GCF. That's out. Next, if it has 4 terms, the only technique we have that will factor this is grouping. So you got to go back to those steps in grouping that I gave you in that 5.5 section, that first or second video. I gave you the steps. Here were the steps. Step 1, group the first 2 terms and group the last 2 terms by underlining them. That was step 1. Step 2, factor out the GCF from each group. Okay, look at these first 2 terms right here. What's the GCF of the first 2 terms? Well, it's x squared, because the x squared goes into both of these. So I take the x squared out. Now, x squared into x cubed leaves x, and then x squared into 3x squared is plus 3. Close your parentheses. Minus. Now, why is there a minus here? Because that's a minus in between these 2 groups. Now, what's the GCF in the next group? 4. So if you say negative 4 into negative 4x, you're left with x. And then negative 4 divided into negative 12 is plus 3. Equals 0. Now remember, the next step in grouping says, if you have a common binomial, grouping works. We do. The common binomial is x plus 3. So I'm going to take the x plus 3 out of both of these terms. Out of this term and this term. So if you divide x plus 3 into this first term, you're left with just x squared minus, and if you divide x plus 3 into this next term, you're left with just 4. And then close your parentheses. Now, this didn't happen in the grouping problems we did before, but it does in this one. And the reason it didn't happen before is you didn't know how to factor this further. Remember, this says to completely factor this. Look at this right here. The difference of 2 perfect square, x and x, perfect square, 2 and 2. So this factors again. X plus 2, x minus 2 is how that factors. But don't forget to bring that down as well. Now, take and set, now it's completely factored. Now set all 3 of these equal to 0. And get 3 solutions, which I expected because this was a cubic equation. Now, in this class, most of the ones you'll run into in your homework are quadratic. Okay, the last thing I want to leave you with is a problem that you do not have to copy, but I just want to show you something, and this will close out section 5.8. Let's suppose I wanted to solve this problem right here. And again, you don't have to copy this down. You'll see why in just a second. This is a quadratic equation, a second degree polynomial equation. All right, I told you if you solve any polynomial equation degree 2 or higher, you have to follow those 5 steps by factoring. Step 1, bring all the terms to one side. Set it equal to 0. Step 2, put it in the right order. Now, step 3, factor this trinomial completely. Well, this is a trinomial. It's the no GCF. It's the easy case. So x squared breaks up x and x. This says signs are what? Different. Largest is negative. So x plus, x minus. Largest is negative. Now the question. I need two numbers that multiply to give you 15 that subtracts, not adds. Multiply 15, subtract 8. If you use 5 and 3 here, that's wrong. 5 and 3 adds to give you 8. I need two numbers that multiply to give me 15 that subtract to give me 8. So this problem is prime. Now, why did I give you this problem? Because I wanted you to be aware of this. Those 5 steps that I gave you, they will solve polynomial equations provided that when you get to step 3, that polynomial is factorable. Well, this is not factorable. So you say, wait a minute, Mr. Rayner, is this a quadratic equation? Yes. Does it have 2 answers? Yes. Here's the problem. The 5 steps that I gave you where we solve this by factoring won't solve this problem because this problem is prime. So you say, so then it doesn't have 2 solutions. Yes, it does. It just means I can't use the factoring process to solve this. You will learn a little bit later on in this course, and then also when you get into college algebra, you will learn that there are other ways to solve quadratic equations other by factoring. So yes, this does have 2 answers. I just can't use the technique in this section to do that because that technique won't solve this problem because this is not factorable. So we cannot solve this one yet. Now, I'm not going to give you any in homework where that's the case. All the ones that I give you in the homework in this section are factorable. But I just want you to keep in the back of your mind, the factoring method is what it's called, does not solve all quadratic equations because not all quadratic equations are factorable. Okay, this concludes section 5.8 video and section 5.8 completely.